Welcome, folks. Today we will be talking about reactivity and how chemical reactions happen, why they happen, and we'll look at some different chemical reactions that happen in our bodies. So first, what is a chemical reaction? A chemical reaction occurs when two or more atoms or two or more chemicals, so think something that has many atoms stuck together, make or break bonds. So we talked about bonds last time we were together. Or share or stop sharing electrons. So that is what a chemical reaction is. Formation of bonds, breaking of bonds, sharing of electrons, or when you stop sharing electrons. And let's kind of learn how we write out chemical reactions. So for example, we'll have a reaction where we have A and B turned into C and D. A and B is what we start with. The chemist's word for this is reactants. The arrow indicates the chemical reaction has happened. That is not how you spell reaction. And then C and D, what we get in the end, that is called our products. So reactant, nice, likely a new word for some of us, but products is probably more of a familiar word. So that's how we write out chemical reactions. So we know what chemical reactions are, and we know how to write them out. But why do chemical reactions happen in the first place? So up until now, folks, what have we talked about in terms of our knowledge of electrons? We know that electrons are negatively charged. We know that electrons live or reside in orbitals that are just these like three-dimensional spaces around the nucleus of an atom. We know how many electrons that different elements have because the number of electrons corresponds with the atomic number, right? The atomic number tells us how many protons an element has. It also tells us how many electrons that element has. And so chemical reactions happen in order for an element or a chemical to fill its valence shell of electrons. The valence shell is a word meaning the outermost electrons or the outermost orbitals. And so what happens, folks, is that chemical reactions happen so that each atom will have 8 electrons, or an octet, in its valence shell, in its outside orbital, in its outside layer. So let's kind of compare and contrast total number of electrons to valence shell electrons. And I want you to take a moment and either look through your notes or look through your old slide back to the periodic table that showed you where the different orbitals are. We learned that this top row of the periodic table indicates the 1s orbital. Then we learned that this next row was 2s. Then as we move right, this was the 2p orbital. Then the 3s. Then the 3p orbital, etc. And we learned that electrons fill from the lowest orbitals and then go higher and higher as they fill the orbitals. So let's take, for example, the element nitrogen. Nitrogen has 7 total electrons. We know it has 7 total electrons because of its atomic number. But how many electrons in its valence shell, in its outermost shell? So to calculate this, folks, we really just want to look at the numbers that are associated with the orbitals. Nitrogen has electrons in the 1s orbital, the 2s orbital, and the 2p orbital. So 7 total electrons in 1s, 2s, and 2p. However, if we're looking at what is in an outermost orbital, that would only be the 2s and the 2p, because the 1s is on the inside and the 2s is on the outside and the 2p are on the outside. Remember from periodic trends, as we add orbitals moving down the table, the atomic radius gets bigger. So that should tell us that we need to look at the outermost orbital. 1 is on the inside, 2 is on the outside. So how many total valence electrons are there? We should not count from the 1s. Let's start counting at 2s, and to make this a bit more clear, let me erase some of this stuff on my slide, folks. Okay, I think that's probably all I needed to erase to make this more clear for us. So let's start counting from the beginning of the 2s and see how many electrons are in the 2s, 2p outer layer. We have 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons. Okay, so while nitrogen has 7 total electrons, it has 5 valence electrons. So if, for example, nitrogen was going to do a chemical reaction, how many more electrons would it need? It would need 1, 2, 3 more electrons in order to have 8 or a full octet in its valence shell. We can compare nitrogen, if I erase my screen real quick, we can compare nitrogen to an element like neon. Neon, if we count how many electrons are in its valence shell, has 1, 2, 3, 4, 5, 6, 7, 8. It has a full octet, a full valence shell. And that is true for elements in this group. These are called the noble gases, and they are generally not very reactive because they are happy as is. They have their full valence shell. So now we know why reactions happen. Now, briefly, folks, let's talk about how these reactions are happening. So a chemical reaction needs to happen when two things, 2 atoms, 2 chemicals, hit each other, right? For them to form a new bond, for them to share electrons, they need to be pretty close to each other. And this collision has to happen with the correct orientation and energy. So for example, oops, my pen, what happened to my pen? So for example, let's fix that real quick. Apologies. So for example, let's say A bumps into B in this orientation. That will lead to a reaction. But let's say A, sorry, it's hard to write sideways. Let's say A bumped into B in a different orientation. He would have no reaction. The same thing is true for the amount of energy. If A bumps into B with sufficient energy, this will lead to a reaction. However, if A just has a tiny bit of energy when it bumps into B, it's likely not going to lead to a reaction. Even if A and B can react with each other, the reaction needs to happen under the right circumstances. And so now we've discussed what chemical reactions are, how to write them, why they happen, and how they happen. Up next, we'll talk a little bit about the different types of chemical reaction.